Going on, fellas? Hope everything's going well for you. Today we're going to be beginning a new section talking about measures of central tendency, and today is going to be specifically devoted to this thing called the mean. The mean. What is the mean, and how can we learn anything about the mean? Okay, so let's first talk about what is a measure of central tendency. Okay, as you can see here, measure of central tendency. A number that helps describe all of the data in a data set is an average, or a measure of central tendency. One of the most common measures, guys, is called the mean. Okay, now, understand how this is going to work. You know, this idea of the mean and the word average, those are kind of synonyms of each other. Those mean kind of the same thing. So, one of the ways we use to describe data is through this use of the mean. Okay, now there are other measures of central tendency. You can see at the bottom of your screen. We're going to talk about this in the next day or two, and that is the mode, the median, and the range. We'll talk about all three of these, but today we're simply exploring the idea of what is the mean. Okay, let's think about what the mean means. All right, the mean of a set of data is the sum of the data divided by the number of pieces of data. Now, let's look at an example of this. The table shows the number of CDs a group of friends bought. Find the mean number of CDs the group bought. Okay, so here's what that's talking about. What it is look back on your definition. We're going to take the sum of the data. So we're going to say 3 plus 4 plus 6 plus 0 plus 2. I'll put a little line through the 0 to make sure you know it's not a typo or any sort of mistake. Now, that's the sum of the data. Now, but the next part of this is divided by the number of pieces. So how many pieces are there? 1, 2, 3, 4, 5. So we'll divide this by 5. Okay, now, do a little bit of addition here. 3 plus 4 is 7. 7 plus 6 is 13. 13 plus 0, then 13 plus 2 gives me 15, and we'll still divide this by the number of pieces of data, equals to 3. Now, what does 3 represent? 3 represents the number of CDs the group bought. So let's write it as that. 3 CDs bought. Okay, B-O-U-G-H-T. 3 CDs bought. Now, let's get in the habit of kind of circling our answer. Okay, so that's an example of the mean. Okay. Let's look at some other examples. This example shows the greatest depths of the 5 oceans in the world. Find the mean ocean depth. Okay, finding the mean ocean depth. Now, what's that going to mean? You have to go back to your previous screen here. Go back to your previous screen. Let's see here. There we go. Now, what we're going to look at here is what is the mean? Remember what the mean is? It's the average. The average, which means that we're going to have to try to find the sum of the data, which means that we're going to have to go 10.92 plus 9.22 plus 7.46 plus 5.63, okay, and then we're going to add 7.24. Now, all of this, guys, will be divided by the total number of data items divided by 5. Now, I'll save you a little bit of time here, and it's important that you're able to add these decimal numbers up accurately. Okay, we're going to have to work on that. Make sure if you have some trouble with it, come let me know. We'll talk through it. Let's look at what that total is. That total gives me 40.47 when you add all these data items together. Okay, you're going to add all those data items together, and you'll divide this by the total number of data items, which is 5. And I'll help you out here. An example, if we divide this by 5, that gives you 8.094. Okay, now, what does this 8.094 represent? Well, that means you need to go back to the problem. The ocean depth, the average ocean depth. So, 8.094 depth of seawater, or the ocean depth. And you can write it as kilometer ocean, O-C-A-N, depth. Okay, 8.094 kilometer ocean depth. Okay, now let's let you try one to see how well you understand the concept. Okay, here's some data. The data is the cost of 15 different backpacks are shown. Find the mean. All right, so what you need to do here, guys, is copy the data down and then take a few moments, pause the video, and come up with the mean or the average backpack cost. Okay, go ahead and pause now. All right, you had a chance to work this. So when you added all those data items together, you should have gotten 510. 510, and there are 15 data items. So when you divide 510 by 15, you get this number. You get 34. Okay, now what does 34 represent? Well, 34 represents the average backpack cost. So $34 back. Uh-oh, I misspelled pack, didn't I? I'm sorry. Try to talk and do something here at the same time. Average backpack cost. So $34 is your backpack cost. All right, how is that for the mean? Pretty easy there. Now, what's going to happen if you have some data that kind of looks a little bit funky? Let me show you what this is called. All right, every now and then, guys, you're going to have something that's called an outlier. An outlier. In statistics, a set of data may contain a value much higher or lower than any other values. This value is called an outlier. Outliers can significantly affect the mean. Okay, now look at this example. Here we have some temperatures on Monday, Tuesday, Wednesday, Thursday, Friday. Notice the temperatures on the specific days. All right, now notice the outlier. On Wednesday, it dropped to 40 degrees. What in the world? Well, you can see what's going to happen. The outlier will affect the mean. Now let me show you on the next screen what exactly happens. Okay, here's how the outlier affects the mean. Now, notice the temperatures with the outlier. The mean with the outlier, this is up here at the top of your screen. The mean with the outlier, that means that we are including this. So notice I have taken the mean with the outlier in the data set, which gives you a 72-degree temperature. Okay, that's with the outlier. Now, look at the bottom of the screen down here. Notice what happens when I do not use the outlier. The mean is without the outlier. So what that means, guys, is that I am now going to find the average not including that data item. So instead of dividing by 5, like I did at the top, now what you see is now I'm dividing it by 4. Why just 4? Well, I did not use the outlier, so that means I took a data item away, and now I am increasing that overall average because you can see the difference. The outlier, or the mean without the outlier, is 80 degrees. And the mean with the outlier is 72 degrees. So, I think you can see how the how the outlier does affect the overall average. Okay, we'll practice this in class. We'll show you a couple of different examples, working with the outlier and working with the mean. But what this is talking about, guys, is we are referring to measures of central tendency. Remember what this is. A number that helps describe all of the data. That is a measure of central tendency. Now, today's case, we're just talking about the mean. Mean can describe data. In the next presentations, we'll be talking about those things at the bottom of the screen. So, as you learn about a little bit about the mean and you practice some of these situations, please make sure that you get your notes written down, and if you have some questions, bring them to class and we will talk about them, all right? We'll see you next class.